Since ancient times, people of many different civilizations have used physical objects to help them solve everyday math problems. For those of you who appreciate a logical reasoning for using math manipulatives, here's a Padlet timeline showing the history of math manipulatives. I'm not going to read all of the dates on this History of Manipulatives timeline in Padlet, but I'll point out that manipulatives have been used for centuries because they're important and they work. Check out the timeline on Padlet if you want more information. Making sure all students begin with the concrete is key to developing a deep understanding of mathematical concepts. It's the foundation upon which higher level math is built, and it has always been a station in table rotation. With the opportunities coming with more technology, we've added another initial. What was CPA is now CPVA, the V being virtual. Through the research of Enrique Ortiz from the University of Central Florida, we can refine virtual manipulatives into 3 digital dynamic sublevels. Sublevel 1 is virtualConcrete. Sublevel 2 is virtualPictorial. And sublevel 3 is virtualAbstract. You note the fine differences between each. Ortiz also noted when it was static and when it was dynamic movement. In his research, Ortiz used images such as these with pre-service teachers and asked them to identify which level and sublevel of math manipulatives were shown. Let's review a few and see how we do. This figure is from an app that helps the learner use tiles to multiply fractions. What virtual manipulative sublevel or levels are represented? If you said the tiles are VP or virtual pictorial, you're right. Did you also notice that there is another level? That represents the virtual abstract. If you've experienced any math training with me, you know how I feel about manipulatives. I love them because of what they've done for me and my students. This extra layer about virtual manipulatives is like icing on a manipulative cake. It is yummy. At this point, some of you may be saying, eek! We know that research proves that students learn best when they begin at the concrete level, but our students can't use the same manipulatives. What about budget cuts and lack of funding? Keeping budgets and accessibility in mind. Here is a suggestion of an individual math tool bag that can be compiled of easy to find and lower cost items. In fact, it's about the cost of a couple of kids' meals from Chick-fil-A. Knowing that some teachers, parents, and caregivers might need a visual to understand how to use math tools that are disguised as household items, the Move Ahead at Home videos were created and uploaded to the Glenna Tabor YouTube channel. Directions for each of the activities are available via free download at glennatabor.com. Let's discuss just a few of the household items placed in each individual math tool bag. I'll share a few concepts that could be concretely experienced with a few of those items. If you don't think that they'll be important to high school students, ask a high school student who's finally held something concrete to illustrate a positive and a negative variable. Where to purchase these? When this update was edited, Amazon, Dollar Tree, and Walmart had the best prices for the items. The first suggested tool is popular with students from kindergarten to high school. It's a bag of buttons, 40 to 45 of them in various colors, sizes, holes, and shapes. The uses for buttons are many. You can find a pattern. You can create the number 5 on a 10 frame. You can have a concrete illustration of an abstract number sentence on a part whole mat. You can even use buttons of 2 different colors for positive and negative integers. Another item that is appealing to students of all ages, 15 to 20 assorted acrylic gemstones. They're also available in big buckets so that you can easily divide them amongst your students. There are many uses for acrylic gemstones. They can replace buttons or be used in conjunction with buttons. Let's look at one concrete illustration of using gemstones to determine the fractional part of a number. Equal sets. There are 3 equal divisions, and one of those has 2 gemstones. So 1/3 of 6 you can concretely see is 2.
Uses for a deck of cards could be combinations of numbers, integers, place value, data creation, fractions, ordinal numbers, combining for a raise to 100, subtraction, order of operations with 4 cards. Oh, and that's just with a deck of cards.
Another suggested tool for your math tool bag is a bag of building bricks with assorted numbers of studs. What are uses for building bricks? You can use them to illustrate fractions, build 3-dimensional shapes, determine spatial relationships, create patterns. Use them to illustrate multiplication and division problems. You can also use them for games such as this Tens and Ones game that's part of the Move Ahead at Home series. You get your building bricks, a couple of number generators, and when you roll, you build stacks of bricks. Then snap them all together and break them into stacks of 10. Now your learners will know that 110 equals 10 individual bricks. For more about manipulatives, visit Module 2, Lesson 3 of the original Table Rotation to Go. You may want to include some of the free work mats that are available on glennatabor.com. There's a pattern work mat, a part whole work mat, 10 frames, and even a point sheet.
The content of the individual math bags of your students is not static, it's dynamic. As the school year progresses and your students begin to share items they find at home that help them understand math concepts, the contents of your individual math tool bags will change. As a learner who never held a math manipulative until I was in college math methods course, I will always use manipulatives. Math manipulatives help students develop conceptual understandings by empowering them to build concrete models for abstract concepts. Wow! Now how incredible is that?